Okay. Welcome, everyone, to this talk about beyond lambdas, the aftermath. So just before we start jumping into the fun stuff, how many of you are using Java 8 today? Fantastic. How many of you are transforming to Java 8? Okay, a few hands. Great. So this talk today is going to be focusing on the new stuff in Java 8, of course, the optional lambdas, streams, functions, and so on. But we're mostly going to focus on the do's and don'ts and the common mistakes as we do as developers. But before we jump into that, let's have a quick word about us. My name is Daniel Deogun, and this is my colleague,
Daniel Sawano. We're from Stockholm, a company called Omega Point, and we're available in Stockholm, Gothenburg, Malmö in Sweden, and we also have a small office in New York. And basically, we help our clients build better software.
Right. So if you're interested in this, please just Google us. But when we started to think about this talk, we said that, well, we've been working with Java 8 since the very beginning of it. And in the beginning, we did a lot of, let's say, rookie mistakes. And after a while, we understood how to do it properly. But then new people came into our project, and they did the same type of mistakes. And then we realized that, you know what? This is probably a paradigm shift in the Java language that creates these kind of problems. So we said...
It was quite interesting, because both Daniel and I have been programming for many years. And not only with object-oriented programming languages, but also functional languages. So we had all that under our belt, but we were still making all these kind of rookie mistakes when we turned into Java 8.
Yeah. So we said, well, you know what? Maybe we should create like 100 slides with all the examples of do's and don'ts, and go over that in 45 minutes, or not. We're developers.
We don't like slides.
Let's show one slide. This is our slide. Let's do some coding.
No more slides, just code.
So let's jump into our first example. Okay, Daniel, so what do we have here?
Well, I guess in this simple example here, we have an advice. We'll check if we do already have an advice, and if we have an advice, we can get that advice for pretty cheap. And if we do not have an advice, we have to go to the all-knowing almighty Oracle and ask for an advice. And as we all know, asking the Oracle for advice can be quite expensive. So we want to do that as a last resort. But it's pretty straightforward.
We've learned to use Java 8 now. Shouldn't we, use some sort of functional way of writing it? I mean, this looks like Java 6 or 7, right? So how would you do this in Java 8?
OK, so if we rewrite this using Java 8, the Java 8 optional, we'll get something like this, right? We wrap the advice in an optional, and if we have a value, we can map it and get the cheap advice. Otherwise, we'll just use or else and get the expensive advice. Easy peasy.
OK, so
just convert it to Java 8.
This looks actually like it's legit, right? But there's actually a problem with this. Daniel, can you run the code?
OK, let's see what happens.
Whoa. As you see there, we are actually getting the cheap advice and the expensive advice at the same time.
That's not really what I want to do, right?
And the reason for that is what Daniel just did. He did a cognitive mapping between the optional or else API and the else branch in the if statement. So how should you have written this instead?
Well, I guess what we do want, if we want to emulate the if-else branch, is to actually get a lazy evaluation of the expensive advice. So if we check what else we have here in the optional, we have something called or else get that takes a supplier. And we can write the supplier in the form of a lambda expression, right? So we pass in the lambda, and suddenly we're only going to execute the expensive call if we actually need it, right? So this would be the proper way to transform the if-else code into optional code.
OK, so to keep in mind, the key takeaway here, don't do that cognitive mapping, because an optional is just a data structure. And the or else method on that data structure is eager. That means that it's going to get invoked every time.
So I guess we can run it and see if it actually works.
Yeah.
OK, so now we're only paying for the cheap advice. That's what we wanted.
So now we sort of warmed up, right? So let's move on to some more advanced examples. Okay.
Okay, so here we have more optionals. Here we have a simple method that takes an optional of some value as an input argument. We then, if we have a value, we will calculate it, we will map it by calculating a new value, and then we will filter it based on some criteria. And then we will map it again by performing a transformation on the value. And at the end, if we didn't get anything from that, we'll just call the or else get that we just learned and perform something completely different.
This really makes me feel good, right? I mean, as a Java 8 developer, I did map, filter, map, just a one-liner. Yeah, all functional, right?
Yeah.
Yeah, feels good.
And the whole purpose of Java 8 is to write one-liners.
One-liner,
right?
yeah.
Well, there actually is a problem in this code. So to make it easier for us to spot that, let's rewrite this into non-Java 8 style.
Non-Java 8, okay. Should be looking something like this, I guess.
Okay, so this is the plain old Java 6, Java 7 style code. We have the first if, checks if we have value, we do all that stuff, and then at the end we perform something completely different. Now, if we look at this code, suddenly it becomes pretty obviously that we're doing more than one thing in this method, right? So we're actually violating the single responsibility principle here.
Right.
Which can be quite problematic.
So this part is actually having one purpose, and this part has a different purpose.
And we didn't notice that because we were so caught up in using all these new APIs, so we forgot about it.
So how should we have done it?
Well, the way to solve this is to actually not perform the forking, if you will, between the first calculation and the completely different, perform that outside of the operation. So if we extract the first calculation into its own method, and call it first calculation in this example, then that method can take an actual value, all right? We're not taking an optional anymore. And then we can perform the calculation, the filtering, and the mapping there, return an optional, and then we can map that, or actually flat map that value, and then perform the completely different calculations. So now our methods are only doing one thing at a time, and we're doing the forking outside.
Okay, so if I understand you correctly, the big difference here is that we are acting upon a returned optional. Is that what you're saying? And then we're doing the forking.
Exactly. So the key takeaway here is that if you find yourself passing an optional into a method as an input argument, that might be a sign of that you're actually doing more than one thing. You're doing more than you should in your method.
But come on. I mean, since we are using optional now as a wrapper of null elements, shouldn't I be allowed to take that data and pass it through some public API? I mean, isn't that what we do?
Okay, so you're talking about the avoid the null pointer.
Right.
Case. Okay, so let's take a look at that.
Okay.
So here we have a different method that also takes an optional as an input argument. It's very simple. It's if we have a value, do something with it, right? But this is actually also problematic. Again, let's refactor this into non-Java 8 style.
To non-Java 8 style, okay. I mean, it looks pretty legit. I mean, it's kind of resilient, isn't it? Pre-Java 8, is that good? And I guess we would take a value t.
And if the argument is not null, then we will do something, right? Pretty simple.
It's pretty straightforward.
So if you take a look at this piece of code, we can see that this is actually what is commonly called as a defensive code construct. We're actually saying that we're going to accept bad data as input argument. We're accepting it and we're pretending it didn't exist by checking it for null, and then we will do something. The problem of doing that is, let's say you have this type of code all over your code base. If you get bad input in your system, that bad input will be able to travel all through your system and then put out something at the end, because you're being resilient, right? You're just swallowing all those nulls. The problem is you're never going to notice if there's a bug happening, right? You're not going to get an exception. Maybe you're going to get some weird output at the end, and if you're lucky, you have a test that will catch that. Otherwise, your customers are going to call you because you have a weird behavior in production. And it's going to be really hard to track down where it actually started.
So I guess what we sort of our intention is that we should do as a fail fast, right?
Exactly. You want to handle bad data as early as possible and not just let it pass through.
So you're saying we should have done it something like this, like using a contract saying, I'm not going to accept null because that's actually bad data, and
exactly,
have it something like this.
So now our method is not going to accept bad data. If you have a null, don't call me. Handle it outside the method.
Okay, so that sort of makes sense. By passing in an optional, I'm passing in a branch, right?
Exactly. The first example, you're passing in a branch. The second example is that you're saying that I'm going to accept bad input data. And we're mainly talking about public methods, right? So you don't want to have optionals as an input argument in your public methods. If you want to have it in your private methods, if you will, let's say you're refactoring your code to make it more readable, that's fine. But really try to avoid using it in public methods.
Okay. So, and the funny thing though, I noticed in the later versions now of IntelliJ, they're actually starting to warn about this.
Probably Eclipse too. So the IDEs are starting to catch up and say, okay, this is a bad pattern. We turned off that warning here just because we wanted to be to show the example, but you're starting to get help from the IDEs. So this really is a bad pattern of using optionals as input arguments.
Okay. So let's move on. Let's see, here we go. It's another stream example now.
Okay, we're leaving optionals and moving into streams, because that's also one thing that is new in Java 8.
And this looks pretty straightforward, if I would say.
Okay, so we have a stream of strings. We will sort it, and then we will collect it and join it all together, comma delimited.
So
Very
that
easy.
makes perfect sense. Why don't you just run it?
Okay, let's run it and see what happens.
Null pointer exception. Well, that's not a big surprise. I mean, we can see that big null there. But what's sort of the point with this example is that as Java developers, we tend to use a stack trace in a particular way. What would you have done here?
Well, instinctively, I would probably reach for this blue line here, click it. It will take me to wherever the ID think I should look at. So, okay, so line 36, what we're doing here, we're collecting and we're joining. So I guess something is wrong with the joining, maybe, or the collecting?
I mean, it could be. But now in Java 8 and streams, we need to start considering intermediate operations and terminal operations. And an intermediate operations in a stream is really something that's lazy. It's lazy by nature. And it's going to get invoked whenever the terminal operation needs it. So in fact, this stack trace is pointing to the wrong location. And now, as developers, we need to start realizing, wait a minute, I need to look further up in the stack trace, which probably we're going to do. If Daniel does this, he's going to find where the root cause is.
So let's start see. Okay, it's talking about something about a comparator. Let's jump into that. Okay, this obviously doesn't handle null, right?
Right.
So this is the source. And so I guess it's actually taking place in the sorting operation.
As developers, we need to understand that, you know what, look in the intermediate operations in order to find out what went wrong. And usually, they're not this simple as this example is. I mean, they tend to be pretty nasty, right? Because people have been writing those one-liners, and it becomes this tall.
Yeah, usually the stack trace will not be this obvious.
No.
As in this example, you might be buried deep in your own backend code and so on. So I guess to fix this example, the problem is actually caused because we have null elements in our stream, right? Which is a pretty bad thing to have. So in this case, the first thing I want to do is to get rid of those.
Right.
So the easy thing is just to filter it out. Guess we can use that. So now we should have a stream without null objects. Now it should work.
Yeah, just run it and see that we don't lie. Of course. Yeah, good. Green stuff works. That's fine. Okay. Moving on.
All right. So here, more streams. In this case, we have an imaginary service with a method called items matching. And you can pass in a predicate into this method, and it will return all the items that matches that predicate. And in this case, we're creating a predicate that checks the ID of an item. So we're basically filtering out an item with a given ID. And I, as a developer that is writing this piece of code, know that the ID of an item is actually unique. It's kind of like a primary key of the item. So I know that if I get anything back from this service, I will get either nothing, an empty stream, or a stream containing one item. So in that case, I can just use find first or find any, because that's very easy just to get the one element from that stream, right? And then if I get that item, I can do something with it.
Okay, I mean, it looks pretty legit. I mean, okay, so what's the problem?
You know, most of you probably written code like this, but the problem here is that what if the service, or the method in the service that just takes a generic predicate, doesn't make any guarantees whatsoever concerning the ID of an item? What if that service actually would return multiple items with the ID of 6 in this case? Then I would get more than one item in the stream. And using find first, I would just get the first item that happens to be returned. And if I would use find any, I would just get any item, right? So suddenly you have an undeterministic behavior in your code. And that's probably not what I or you wanted when you wrote this code.
Wait a minute. Are you saying that this piece of code is actually giving me a non-deterministic behavior?
That's exactly what I'm saying.
Wow. Try to find that
Let's run
bug.
it and see if I'm right.
Okay, let's run it. I mean, this sounds crazy. So I got item 6.
Got item 6, and the name or the description is item 6 parenthesis 8. Let's run it again.
Oh, 9. Wait a minute.
Run it again. We get different. Okay, so obviously we have multiple items with ID 6. So this is not what I intended. So what I want to do is I want to make sure I only get one item or 0 items. And one way to do that is to use a beautiful operation in the Streams API called reduce. And reduce takes a binary operator. So what if we pass in a binary operator that will always throw an exception, right? The reduce method or the binary operator will be called if there is more than one element in the stream. It's not going to be called if there's 0 or 1 element, right? So if there's more, I'm saying that something bad happened. This is a bug that I didn't expect, or a behavior I didn't expect, so I'm going to throw an exception. So now I protected myself from this behavior that I didn't expect. So if we run this code again, we should fail.
Okay. Let's see. Oh, yeah. Found multiple items with ID 6. Wow.
And obviously, I guess we can show that it actually does work. Let's change the ID to, say, 4 or 5 something.
5.
I happen to know that the ID of 6 has duplicates. So
okay.
Item ID 4, let's see if it works.
Oh,
so
yeah.
Now it works because there's no duplicates.
But Daniel, okay. The first one with find first, I mean, that was pretty. This looks kind of nasty. How can I?
Your eyes are hurting, right? So I guess we can prettify this. We can Uncle Bob it.
Okay, I'm going to Uncle Bob it. Okay.
Extract that into its own method. Make it more readable.
2 exactly 1. Is that good?
Yeah, that's good. Okay, so now my eyes are happy again.
So that's pretty neat. That means that we can actually create either a library of these kind of functions. We can increase readability and make it more understandable. And at the same time, we can enforce our contracts on this particular behavior that we expect.
Exactly. You're explicitly checking the invariant that is applied to the ID of the item in this case.
Okay. Nice.
So the key takeaway here is that whenever you find yourself writing code like this and you just find first, find any, because I know in the back of my head that something is legit, then don't do that, because you probably do not want this non-deterministic behavior. Use reduce instead, in case you just want one element.
Okay, great.
Let's move on.
Let's move on. Here we go. This is another stream one.
In this example, we have a user service and an order service. Let's pretend this is a typical web application, right? So in our application, we can ask to get the currently logged in user, right? And then we can get all the items that the user wants to buy. Maybe she put it in a shopping basket or something. So we create a stream of all the items. Then we can create orders for all the items, and an order simply contains the ID of the item and the ID of the current user. And then we can send all the orders away to the order management system by using the order service.
Okay.
Pretty straightforward, right?
Yeah, it looks pretty good. Should I run it?
Yes.
Okay, let's do that. Oh, so we sent 30 orders.
Okay,
but
30 orders, it works.
But it was kind of slow, wasn't it?
Okay, it's a kind of slow performance. So what can we do about that?
Well, I mean, I've been reading about Java 8, and all of you that's read about Java 8, what's this thing that we all encounter? Parallel streams.
Ah, the good old parallel streams. There's not a single Java 8 talk that doesn't mention parallel streams. It's pretty cool. And parallel streams are cool. So let's convert it to parallel streams. See if it works.
Yeah,
And as a disclaimer, you know, this isn't being an academic example. Whether or not in real life using parallel streams will give you better performance in whatever you mean by better performance, that's a totally different discussion. But in our case, we decided, okay, we think parallel streams is going to increase the performance of our system. So let's try it.
See how easy it was for me to just, you know...
That was one major refactoring.
Yeah, I mean, just parallel streams. We're done now, right?
So let's run it, see what's happened.
Okay, let's do that. Oh, wow.
It failed.
It failed?
We changed so little. Okay, what does it say?
I don't know. Illegal
No
state.
current user found.
Okay.
Where's that thrown?
I don't know. I'm just going to follow that blue link like we should, right? Yeah.
Okay, so apparently the user service does not return a user anymore.
Okay. Should we jump into it?
Yeah, jump into that code and see what it does. See if we can find something strange going on. Current user get. Oh, see that? That's a thread local variable in our library for getting users. So what happened when we converted our stream into a parallel stream is that all the operations are going to be executed on different threads, especially a different thread comparing to the one that you're currently in when you're writing a code. Right? So the thread local variable is set in the code that you're in, but it's not going to be set in the thread that happens to be executing your code in the underlying fork join pool of the stream, right?
Okay, so you're saying that since we have this implicit dependency to the current user, obviously, we need to make that explicitly if we're using multiple threads.
Exactly.
Ah, okay.
Remove the implicit dependency to a thread local context.
Okay. So in that case, I'm just going to extract that now.
Sure.
Is that good? So I'll extract
so what Daniel
it.
just did here is he extracted the user, and then he's passing in the actual user to the intermediate operation. So the intermediate operation does no longer depend on a thread local.
Okay, so I'll run it again, see that it actually works now. There we go. Oh, wow. See, that went lightning fast.
Okay.
Yeah.
So apparently, even though we have this really powerful tool called parallel streams, it helps us a lot, but it doesn't remove the need to think about concurrency and multi-threading and all the problems and challenges we have. You know, like Brian's book is still valid, right? About concurrency. So obviously, again, in real life, it's not going to be as easy and obvious to find the error. So if you don't know what libraries or frameworks you're using really well, you might run into these types of problems.
So I guess the key takeaway here is that, you know, be really careful about just changing stream to parallel stream. I mean, you get all the problems you have with concurrent programming.
You still need to think about concurrency. Let's move on.
Let's move on. Okay, here's another stream example.
Okay, so here we have a stream of JSON data, strings actually. So let's map all those JSON documents into users.
Okay.
Using some kind of JSON parser library. And then we collect all that, and then we can send off a coupon, I guess. So let's run this and see what happens.
Okay. I mean, this looks pretty normal, doesn't it? Yeah. So I sent, let's see here. Let me scroll this one up. I guess I parsed 20 users, and then I sent a coupon with 15% discount to 20 users. Oh, this is the spam service on the internet.
Yeah, this is the spam bot.
Yeah.
But okay, it works. But what happens, let's say we introduce some bad data.
Okay.
Some bad JSON that causes the parse function to throw an exception.
Oh, I have a method called bad JSON. That's good.
That's by coincidence. So now we're getting bad data, right?
Okay.
So what's going to happen here?
I don't know.
This.
Okay, let's see. Oh, whoa!
So we get an exception as we expected. So if you scroll up, we can see that we're processing all the items, or the users, sorry, up to the 12th, and I guess user number 13 is bad. So we stop there, the processing stops, you get the exception, right?
See, this is something that really bugs me also as a developer. I mean, those exceptions that occurs when you start using streams, it's not really natural. How should I deal with this then?
Well, it depends on how you want to deal with them. One easy thing to say is, okay, if I get bad data, I'm just not going to send any coupons. I'm just going to log the data. I will place a good old try catch surrounding the entire stream operation, and I will handle the exception.
Okay.
So let's see how we can do that.
So
that's the easiest version.
That would be something like this, right?
So we handle the error, log it or whatever, and then, okay, something bad happened. So let's run this and see how this turns out.
So there we go. Oh yeah, I mean.
Okay, so now we're handling the error and still not sending any coupons, but we handle the exceptions. Our spam bot will continue to survive. Okay,
so the important thing is that we stopped our computation and then we did not send any coupons. But
it's basically just like a good old for loop, right? You're iterating the for loop, something blows up, you stop.
But at the same time though, I'm working with streams, and a stream is like an infinite data structure with data flowing. Should I just stop when I just get one rotten apple?
Okay, you're saying that you actually want to continue with the good users, right? Okay, so how can we do that? Okay, I guess if we were writing a for loop, we would just put the try catch in the for loop, right?
And then continue.
So how do we do that in a declaration of a stream? Well, what we can do is, let's say we wrap the parse JSON method into our own method that we call tryparse. And if we get a user back, that method will return a stream with a user. And if we get the exception, again, we will handle that exception, but we will return an empty stream. So now our intermediate operation is tryparse. That means that we're going to get a stream of streams. So instead of map, we will use flat map, and then we're back to a stream of users. And then we can collect that and send coupons.
Okay.
So if you run this code, we should send coupons to, 19 users?
Yeah, let's see. Oh, that worked.
Yeah. So now we're not letting that one bad piece of data destroy the rest of the stuff.
Okay. So this looks pretty neat. I agree. But didn't we say, like in the previous example, when we talked about the API, I mean, the tryparse here is something that's probably going to be reused in multiple places.
Yeah, you're probably going to do this. So you come up with this great idea. Okay, let me extract that into a user JSON parsing library that everybody can use in my company. But when you do that, as you said, you need to start thinking about readability, because suddenly you're making a public API. So if you have a public method that returns a stream, to me, that method signature tells me that it can return 0 or more users. But what you actually want to say is that I can return 0 or 1 user, right? So if I would convert this into a public method and put it in a library, I would return an optional instead. That's a lot more clear. You can only get 1 or 0, right?
Okay. So I guess I'll do that then.
Yeah.
There we go.
So if we do that, then you will end up having instead of having a stream of streams, you will have a stream of optionals, right? And then you want to flat map your way out of that. So what you want to do is convert the optional into a stream. And as of current in Java 8, you can't do that. There's no optional.stream method. It probably will be in Java 9. So you have to write your own little utility method for converting an optional into a stream. So then you have this extra step of first you map by using your tryparse, and then you have to get rid of that stream of optional by flat mapping the stream of those optionals, or the streams of those optionals.
Okay, so I guess the key takeaway here is that, working with exceptions is kind of a nasty thing when it comes to streams. And we need to treat it a little bit differently, comparing if we're using a public API or if you have an internal one, right? Or
yeah, well, that aspect is the design aspect. And of course, again, as you said, if you want to continue, you need to handle the exception within the intermediate operation. You can't just throw it away or throw the exception, because then it will terminate the entire stream operation.
Okay, but what about, parallel streams? I mean, that was the thing that we worked before, right?
We're supposed to talk about parallel streams, yeah, because we're supposed to be hip. So the good thing is all these examples applies on parallel streams too.
Okay.
Right, so if we convert this example, for example, into a parallel stream,
okay, let me just add that.
It will work just as fine. It behaves the same even though there's multiple threads going on under the hood. So you can actually run this.
Should I run this? Okay. There we go. So what we have here?
The only difference is that the JSON is being processed in a random order.
Yeah, I guess if I run it multiple times, you will see that, right?
And the previous example where we had to try catch surrounding everything, that will also work just the same, with one little slight difference. If we take a look at how that example would look like, if you're running in parallels, with a massive try catch.
With the try catch in it? Okay.
Yes.
Should be something like
if you run this, you will see that it will behave the same. You will get the exceptions. You're not going to send any coupons, right? Run it, please.
Okay. Oops, sorry about that. There we go.
So we're not sending any coupons, just like before, when we didn't have parallel streams. The only difference, you can see that you're parsing a lot more users, right?
Yeah, that's true.
In the non-parallel example, we were just kind of sequentially iterating and then stopped. In this case, we're going to parse a lot more because it's all taking place in different threads, and it's just one thread is going to experience an exception, right? So that is a good thing to keep in mind, that you're going to process more, even though you're going to end up with an exception and not getting anything back from the stream.
So wait a minute, you're saying that, just to reiterate, if I remove this parallel here,
yes,
and I run this, we are only going to yes, okay.
We only parsed, in this case, 12 users, right? So there's a difference there. And if you have written methods or intermediate operations that are not side effect free, you need to keep that in mind. But you should always write side effect free functions, right?
Yeah, that makes sense. Okay.
Or if you're doing very expensive processing, that will cost you too. But the end behavior will be the same regardless of whether you're using parallel streams or not.
Okay. Good. So let's go on.
Yes.
Let's see here. Should be 10. There we go. Right. So now we're moving over to
the car domain.
The car domain, or functions and lambdas. One of the cool features in Java 8 is, of course, the function API. And, well, we figured a good example of this is, of course, to talk about cars that we don't know anything about. So, I mean, we're from Sweden, so we're going to build a Volvo. And then, since we are, environmental friendly, we figured a Tesla. And the only difference between these two cars is apparently the horsepower. So Daniel, just run the test and see that it actually is true. Yes, that's true. That's the only difference.
So Tesla has 1,000 horsepower and a Volvo only 250.
But when we started to, build a Volvo, all suddenly business came along, and they said, you know what, you're going to start building Teslas as well. And as engineers, we figured the dry principle was, something we need to adhere to, right? So we created a generic car factory.
So we extracted that from the Tesla and then said, okay, we can reuse this in the Volvo factory.
Oh.
Perfect.
Okay, that makes sense.
We actually designed the generic factory so we can pass in whatever is creating the engines, right? You're using the strategy pattern here.
So we are injecting the behavior of constructing an engine into something that's generic by using the function API of Java 8. That's pretty cool, right? But all suddenly, business comes along. And they said, you know what, a Tesla engine is a bit different from a Volvo engine, I guess. It needs an alternator. So Daniel, can you just add an alternator in that engine?
Okay, so I'll jump into the Tesla factory and see what I can do. Here's where we create the engine. Let's poke around. It turns out the factory can actually create alternators too. So I got my alternator, and then we wanted to pass that into the engine.
Right.
Because the engine appears to be needing an alternator, and then we implement this later, right?
Yeah, I do stuff, whatever.
Okay, great. So now we're done with that. I guess we can inline this to make it pretty.
And of course, we're using, continuous delivery and all that stuff. So push this into the pipeline, and we can get out of here.
Okay, so let's run our tests again.
Whoa!
Oh, what's that? Dude, I hope this is not because I took some of the code from Stack Overflow last night.
Yeah, that's a web page.
Yeah. Okay, no, it's actually okay. Now I get it. It's got infinite loop, right?
Right. So we have infinite recursion going on, and the question is why. So let's go back into the generic factory and take a look at the code there. Here we go. So if you look at the alternator code, you can see that, well, the engineer who constructed this, he or she reused the engine strategy. Apparently, they failed to make the dependency to horsepower explicit. So for some reason, that's important to selecting an alternator. If it's greater than 400, it should be a badass one, and otherwise a normal one. And by doing that, they created an infinite loop. But neither the compiler or the IDE warned us about this. So imagine this going across modules, multiple invocations, and you just add one additional call, and all of a sudden hell breaks loose. And there's another problem with this. Daniel, can you go back to the Tesla factory? What's the access modifier of that engine method?
This one, it's private.
It's private?
Yes.
Are you saying another class can actually invoke a private method in your class?
Yeah.
Wow. Bye-bye encapsulation.
It's like pseudo public. Oh, okay.
No, I mean, this is kind of, for me, this is serious.
Okay, now, I mean, obviously, you can do this without Java 8, right? You can create like interfaces, things like that, strategy pattern, all that. But it just becomes so easy when you have this function. You just write lambda and everything. So you kind of forget that you're doing this, right?
Exactly.
It's harder to spot.
So I mean, the key takeaway here is that if you use the function API and you inject behavior through it, in this way, if you want to prevent dry or whatever you want to do, make sure you know what you're doing. This could be dangerous. It becomes really nasty when you start refactoring and writing tests for this and so on.
And even if you don't get this Stack Overflow exception, you can create these cyclic dependencies between packages and modules without even noticing it.
Yeah.
And it's become really hard, but as Daniel mentioned, your IDE is going to have a really hard time trying to find that when you search for it. But what are you going to search for? You're not referencing any classes, you're just passing in generic functions.
Okay. Moving on.
Yes.
B11, 14. There we go. Okay, so let's move on to our last Lambda example, which is a very complex one.
This is not complex. I'm just doing stream, filtering a stream of strings, checking if it contains a pattern, collected to the list. What's complicated about that?
Well,
is this supposed to be the grand finale?
I mean, seriously, there's a lot of experienced Java 8 developers out there who doesn't know the difference between stateful and stateless lambdas and capturing and non-capturing lambdas. So Daniel, is this a capturing or non-capturing lambda?
Well, by looking at the code, I would say this is actually a capturing lambda, right? And I noticed that because the lambda itself is using this pattern field that is actually a field in the instance that I am in, right? So it's capturing that.
Right. Okay. What about the stateful and stateless?
Okay, let's see. Can I declare a lambda to be stateless or stateful? Can I write something like this, or how do I?
I mean, what we want to strive for when we write lambdas is really stateless, non-capturing lambdas, because those are more performant.
Okay, well, wait a minute. I actually read something about that. I think we need to go down to the basement to actually be able to reason about this.
Yes.
We need to go down to the bytecode, right?
So while Daniel is moving over there, every lambda that you have in your code gets translated into its own method. And if you want to get an understanding of it's stateful or stateless, we can inspect that method. And if it's static, it becomes stateless. And if it's an instance method, it becomes stateful.
So I'm compiling the code, and then I'm decompiling it using the Java Peach tool. And hopefully you can all see this.
Yes.
So if I check this, okay, here is the method that our lambda ended up being. And if you look at the, I guess here is where we're actually calling the lambda by using invoke dynamic. So our lambda turned into an instance method.
So that means that it's actually stateful. And we're not getting the perfect performance out of it. So how would you, I mean, is there a way we can create it into a static method?
Okay, so we want the lambda method to be a static method. Actually, if I remove the use of the pattern here from the lambda itself, and then the simplest way to do it is just extract it to a local variable. And then our lambda doesn't use the pattern field anymore. So this should make the lambda method into a static method, which would turn the lambda into a stateless lambda.
Okay, let's look at the bytecode again and see that it's actually true.
Let's compile it, because we all love a bit of bytecode in the morning, right?
Wow.
Here. Oh, it's static.
Fantastic. So you actually did that. But you know what? Yeah, we can all smell it, right? If you go back to the code, he started refactoring war.
Yeah, true. If I would see this type of code, I would go, what is this type of local variable that is uncalled for? I'm going to inline this shit. And then you're back at square one, right? And you lost all your performance. So a better way, or an alternative way, would be, I guess again, we can Uncle Bob this.
Should we Uncle Bob it? Okay, let's Uncle Bob it.
So we're extracting this into this lambda into a method.
Say matches, or okay.
And that method will take a pattern as an argument, because again, we do not want our lambda to reference the field. So now the lambda is referencing a local variable, right? And suddenly this actually reads better too, because in real life your lambda expression doesn't tend to be this short and concise. They can get pretty nasty. So I would say a lot of times this will read better too.
Wow.
So this should be the same end result. We should still have a stateless lambda.
So why don't you just compile it again and run the bytecode, the Java P tool, and then we can see this actually static. Okay.
So it's still stateless.
Okay, so it's stateless. That's fantastic. And what about the capturing and non-capturing?
Well, in this case, it's non-capturing, right?
Because we don't have a dependency to this in the lambda, right?
Yeah.
Okay. So what if I would inject this as my parameter to, matches function there? What would happen then? Would I create a stateless capturing lambda?
What you're trying to, okay, so let me see if I get, you're passing in that, so you're saying, oh, now I'm not depending on this anymore, I'm just depending on an instance of a class. Okay, well the thing is, you're actually still capturing.
I'm still capturing?
Or you converted it into a capturing.
Okay.
And you can't really tell that by looking at the bytecode, but you can reason about it. Because you're accessing a field of a particular instance. Right?
Okay, so if you would compile that again, it will still be a static method, right?
It's still stateless.
Okay. All right. So we would actually have a stateless lambda, but it's capturing, and this is nothing that we want. No, we want to make it stateless and non-capturing.
If you want to maximize your performance, and again, I mean, when we say performance, I mean, it's not super bad. It's going to be like, okay, you can perform like an inner anonymous class, so it's not that bad. And again, we're not saying that you should think about bytecode level performance when you write your everyday code. You should always think about readability, good design, all that stuff, but it helps to know what happens under the hood in the rare cases that you actually need to think about the type of performance. But
this is a really neat tool to have in your toolbox, though. If you're doing heavy data mining, processing, and you're not getting the performance that you want, maybe this is the problem.
And then also, don't go extracting every single lambda into a method. You would get too many methods. But again, focus on readability, and you might actually end up with more performant code.
All right. So I guess that was our last example, and we have like 2 minutes and 42 seconds left for some questions.
So does anyone have any questions?
Okay, so the question was, could you please recompile the code and show the difference between capturing and non-capturing? Well, what Daniel just said here before was that you can't really in the bytecode because that's something you have to reason about. Do you have a dependency to this or not? So that's the problem.
A question there.
Sorry.
Okay, if I finalize the stream, can I go back? You mean if I perform a terminal operation, can I reuse the stream? Is that what you're asking?
You put the parallel, okay, in the stream. Can you go back to original order of elements?
Number 11? Or this example?
I don't think. Yeah, come up on stage, please.
Okay, the question is, you put the parallel in the stream. Can you go back to original order of the elements that there was in the stream at beginning? Because, for example,
no, you can't.
You cannot.
No. So the question was that if you use the parallel stream, can you ensure the ordering?
Yeah.
Really? And no, I mean that's going to use an executor service under the hood, and of course that's going to get executed in whatever the scheduler thinks is appropriate.
So, unless you start passing in your own executor service.
Oh yeah, you can create your own, of course, and then it's a bit different. Okay, thank you so much.
And if you want to, please vote for this talk on the app.
Yeah,
we
please
appreciate
do.
the
You want to come back?
We'll be around if you want to ask more questions. Thanks.